We good, Wenjin? Can you hear me? Yes? Okay. All right. So we are already actually at the second part of heat. Money, we did heat, I think, twice already. This time round, we're going to do a little bit more challenging questions. We're going to try a bit of open-ended questions. Okay, because I think heat is a topic that is quite difficult to grasp in terms of the concept because you can't imagine, you cannot see, you cannot really see heat. Okay, it is a form of energy, so you will only be able to feel it, right? Something is hot, and then you will have to try to visualize and try to imagine where does heat actually gets transferred. So I think the rule of thumb is that heat always travels from a hotter region to a colder region. Okay, right? Okay, so just a quick recap. I know it's a lot of words here, but mainly some of the key ideas. Okay, let me just use a highlighter. It's a form of energy, right? So we must know another very key information is that heat and temperature are different. Heat is a form of energy, whereas temperature is a measurement of how hot an object is. Okay, and it's usually measured in degrees Celsius, right? Heat always flows from a hotter object to a colder object. Yeah, until both objects reach the same temperature. Okay, so some key concepts here. Number one, it's a form of energy, number one. Number two is this part here, heat and temperature. Number three is that heat always travels from a hotter region or hotter object to a colder object. So it's really important that you use the correct terms when you're explaining the transfer of heat. Okay, please do not invent your own terms like gain coldness. Nothing, no such thing as gaining coldness, only gaining heat or losing heat. Okay, all right. I know you might not have learned heat in school, Wenjin. You haven't learned heat in school, right? Heat is usually one of the last few topics, but at 88, I think we are going a little bit faster. Okay, don't worry about other topics. We will always revisit and revise on it. Yeah. Okay, so let's take a look at this question. The image below shows a cup of hot coffee. Susan touched the side of the cup and it felt hot. Explain how the cup became hot with the hot coffee inside the cup. Okay, so firstly, you must always ask yourself, where is the hotter region? Of course, the hotter region is the hot coffee. Okay, and the concept that we know is that heat always travels from a hotter region to a colder region. Okay, so when Susan definitely touched it with her, right? She used her hands, right? Her hands to touch the cup. Yeah? So how it became hot, how the cup became hot with the cup. Oh, okay. So now the question is asking to explain how the cup became hot. Okay. So of course the cup is the cooler region. It's not that it's cold, but it's just cooler than the hot coffee, which is the hotter region. Okay. So how do you explain this? Therefore, the answer is the cup, which is the cooler region, gained heat from who? From the hot coffee and became hot. So here are some keywords that you have to have when it comes to answering heat questions. Are we clear so far? Wenjin, are you okay? Wenjin, which school are you from?
Tanjong Katong Primary.
Oh, nice. So you're living in the east, huh? Tanjong Katong.
I already know this topic.
Oh, you've learned this topic before? In your school? Oh, okay. That means your school did heat first. Yeah. Okay, of course, at 88, sometimes different schools do different topics. So we do have our own curriculum as well. Yeah. So don't worry if you have not learned it. I think we still do our fair share of teaching as well. So just keep an open mind and then you'll be exposed to the different topics. Yeah. Okay. All right, let's move on to the second part of this question. So same thing is Susan and her cup of coffee. Yeah. So Susan measured the temperature of the coffee over 30 minutes and recorded her results in the table below. Okay. So explain why the temperature decreased. Okay. So explanation question, temperature decrease. So usually when it comes to explanation question, okay, you do need to make reference to the results. And of course, in this case, the results are in the form of a table. Yeah. So you notice that it has decreased over the 30 minutes. Okay, there is a decrease. Okay. So therefore, why did the temperature decrease? Think about heat gain, heat loss again. Okay. So of course, the heat is being lost from where to where? Where's the hotter region again? Anyone? Where's the hotter region? Yes, Money?
The coffee,
Very good. So where do you think the coffee lost heat to?
the surrounding,
Very good. Yes. Okay. So lost heat to the surrounding, right? So see the cup of coffee. How do you phrase your answer? Lost heat to the surrounding air and became colder. And eventually it will become room temperature because it will then become the same temperature as the surrounding eventually. So this is how you actually cropped out your answer for open-ended heat questions. Okay? Any questions so far? Wenjun, you okay? Yep. Okay. Okay, so now we are going to go through. I have seen your responses. I think Mani, you actually tried to open up the homework, but you didn't attempt everything.
I did everything.
Oh, you did? Let me check again. Yeah.
There was some
Because
of the questions wrong. One of them they just said blue and gray. They never said like it's correct or wrong the answer.
okay, let me just double check. Yeah.
I did no attempts. I just checked the results.
Yeah. Okay. I think because when I was checking your answer, you just did it recently, is it? Today?
Yes.
Oh, no wonder. Because I marked quite early today, about 2, 3 p.m. So maybe when I checked, it wasn't done. Yep, I see that it has been done. 9 correct. Okay. All right, Wenjin, I've also seen your results. So we will go through some common mistakes. Okay. Yeah. Let me just have a look at Mani's results again. Okay, let's do this. First question. Okay, first question, I think Mani, you did not get it right. Let's see if Wenjin has gotten it correct. Yeah, first question, both of you have gotten it wrong, actually. Okay, so let's have a look at this question. Alvin wants to measure the temperature of hot water in a beaker. Which one of the following diagrams shows the correct position of the thermometer when taking the temperature reading? Okay, so of course, it has to be, okay, in this case, it has to be D, right? Because I think some of you chose C. Yeah, because this one, the bulb, okay, this is what we call the bulb of the thermometer. Okay, the bulb of the thermometer has to be in the object that you are measuring. Okay, in the object which you are measuring for its temperature. So of course, these two are out because this one is not measuring the temperature of the hand, it's actually measuring the temperature of the water. Okay, and A is out because if you notice, the bulb is outside of the water. So therefore, the answer is D. Okay, so using the meter is actually part of your syllabus. So you are expected to know how to use a thermometer. Okay, now next question. Next question is an open-ended question. Question 2. Let me have a look at Mani's word. Okay, both Mani and Wenjin, I think first part A is not an issue, but part B and C, I think your answers were not very complete. Okay, so never mind, we'll go through one by one. Now this one, Rashid conducted an experiment using setups X and Y as shown below. He wrapped a glass beaker with material A and another identical glass beaker with material B. Okay, so he measured the temperatures of the water over a period of time and plotted his results in the graph shown. Right. So what happened to the temperature of water in setups X and Y after some time? I think this one, both of you got it right, so I will not go through so much. Basically, they both decrease and reach room temperature. Okay, some of you put they both decrease only. You have to make sure that you actually explain the entire graph. Because eventually they actually reach the same temperature, which is equilibrium. They reach the same temperature as in room temperature. Okay, so this one is fine. I think you're quite okay. Now, next question. Explain. Okay, explanation question. Why temperature of water in setup Y decrease at a faster rate? Okay, so I think you all did mention things like material A is a better conductor of heat than material B, but the answers are not complete, especially for explanation questions. Usually explanation questions are 2 marks. Okay, so if you were to say that it is a good conductor of heat or a better conductor of heat than than material A, then you have to make sure that you have this inside as well. So what do you mean by better conductor? It will gain heat from the hot water faster, and the temperature of water will decrease faster as well. Right? Any questions? Wenjin, are you okay? Yeah, Money? Yep, good. Okay. So I think a lot of you only wrote the first part, and that's not enough. This one will probably give you 1 mark. But you need to make sure you say that, oh, it gained heat from the hot water faster, and the temperature will also decrease faster as well. Okay? Do you need time to write down the answer, Money?
No, actually, my printer broke down, so I couldn't print my worksheet for the English lesson and this lesson.
Oh, okay. Then if that's the case, you can actually take a foolscap paper or something to write down as well. Just take down some notes. Then once your printer is up, you can maybe just staple it together.
My teacher for English, she actually told me, in day tuition, there's slides like you can re-look at the slides once you're done.
Yeah, that's true. Yeah, correct. That means after our lesson, right, the annotated slides will be uploaded to your student account. So actually, you don't really have to write down the notes.
That's
Yeah,
why
so
I told my father, no need to worry. Later was we can print and maybe on the weekends I'll copy the notes.
yeah, and also I think sometimes unless you find that copying is better for you, like copying will help you remember, then I think then you can do that. Yeah. Okay, let's move on to the next question. Material A in setup X has small air spaces and is used to make cooler box to store frozen food. Explain why material A will help to keep the frozen food cold for a longer period of time. So, because these air spaces, okay, what are air spaces? Air spaces are good or poor conductor of heat. Wenjin? Wenjin, sorry?
Bad conductors of heat.
Very good. Okay, we usually use the word poor instead of bad, right? So it's poor conductor of heat. Okay, very good. Air is a poor conductor of heat. So what happens is that when you have air spaces in between, the frozen food that you want to keep frozen and cold for a long time will not gain heat so quickly from the surrounding. Okay, so that's how the frozen food can be kept long. Yeah, so here's the answer. Air is a poor conductor of heat and it will slow down heat gain from the frozen food to the surroundings. Okay, so air is a poor conductor of heat, right? So this part here, you address the heat first. This one also is a 2-mark question, yeah? So air is a poor conductor of heat, 1 mark. So what if it's a poor conductor